If you have an Ender 3 or an Ender 3 Pro, you may have been told about this little trick to avoid an issue where you would cause binding from the lead screw to the lead screw nut. And that would be to back off these two screws right here just a little bit so that the lead screw nut can wobble in place, so that way the lead screw doesn't bind when you're moving up and down. Now here's the thing, when you do that, what you're doing is you are compensating for the misalignment of the lead screw and the stepper motor shaft, because for whatever reason, in many cases where you have binding, it occurs because the lead screw isn't actually straight up and down, it's at a very slight angle in any particular direction, depending on how you have it set up. And by having these screws backed out, you allow some wiggle room, which gives the lead screw nut the freedom it needs to ensure that it doesn't bind on the lead screw. However, that is not the right way to handle this. It's a band-aid, and it doesn't really address the problem. So, the problem, as I had just said, was when there's a misalignment between the lead screw and the stepper motor shaft. Because, try as you may, unless it's a type of stepper motor where the lead screw is actually physically connected on the inside of the motor, which you don't really see all that often, there's going to be some misalignment. You're not going to get everything perfect. And in a system that demands perfection for freedom of movement, that can be an issue. But you'll notice my screws are not backed out. In fact, they're all the way down. I also have an anti-backlash nut. I also have bearing blocks on the top to stabilize the lead screw. I also have everything tightened down, but what you may have noticed that is different compared to your standard Ender 3 is the coupler that connects the lead screw to the stepper motor shaft is not the stock one. This is what is called a spider coupler. And this is the type of coupler you would need to compensate for small misalignments between two shafts that are being connected to each other. Now, because of that spider coupler doing what it's doing, allowing some freedom of motion for the lead screw to kind of turn without binding, I can have everything tightened down. I can use my anti-backlash nut, which makes things a bit more kind of rigid in certain senses. That's there for a different reason, but it does make the tolerances a little more tight just by its nature. The bearing block has got this shaft in a situation where it cannot move in any direction. It is in a fixed position, although it does rotate. And that's what spider couplers are there for. They're there to fix that minor, keyword minor, discrepancy between the discrepancy in the angle of one of the shafts that connects to the spider coupler. You don't have to get a very expensive one. These cheap ones often will do, and in the case of 3D printers, they're usually the red ones. Different colors denote usually a different resistance to freedom of movement. So these red ones are relatively soft. Now you can get some very, very nice ones like what I have from 3D Passion, but the result is ultimately the same. In other words, don't compensate for a misaligned shaft by backing out these screws right here on the lead screw nut. Compensate for it where it should be compensated for, with the coupler. So, little tidbit of information there for you. Once you have the proper solution in place, you should be able to tighten everything down, and everything should still move, or in this case, rotate freely, without binding.